All right, good morning, guys at home. Can I get a thumbs up that you hear me and see the board okay? Good, all right. Camera should be on, let's do this. All right, so yesterday, I showed you how to divide polynomials when one polynomial of more than one term is divided by another polynomial of more than one term. We have to use long division. Now, I did say there is going to be a shortcut to this. Now, with that being said, the shortcut doesn't work for every single type of dividing polynomials. It only works for a certain kind. Luckily, it's the kind that we see a lot, so it's going to work for us. However, there is going to be a time where it can only be done by long division. There will not be a shortcut, so it is important. Oh no, I got kicked out of the meet. Oh, am I here? Guys, am I here? I just got kicked out of the meet, or now you're all blank.
We can hear you.
You can hear me? Okay, because the screen's going crazy. Can somebody just do me a favor? If you lose the hearing, can someone just unmute and let me know? Because my screen's going very, very wonky right now. All right? So there is going to be a time where you have no other choice but to do long division. So I left you guys with this one. I do feel better if I go over it just because it had that 0 in it, just so everybody sees how we approach that. So I left you guys with setting this one up. How many times does x minus 3 go into this polynomial? So you have to look for missing terms, right? So if it's going to start with an x to the 4th, then you have to count down sequentially for each term thereafter. So then there needs to be an x to the 3rd. There wasn't, so we had to fill one in. Now, I don't want to change the problem, so I put a 0x to the 3rd because there really aren't any, but now it's placeholding for any x to the 3rds that might need to be in my answer. All right, and then we have x squared, x, and a just number. All right, so here we go. So divide, multiply, subtract, bring down, repeat. So the first step, you should be asking yourself, how many times does x go into 2x to the 4th? But I like to think of it as, what could I put up here so that when I multiply with x, I get a 2x to the 4th? Because I have to match this. And I need a 2x to the 3rd. So 2x to the 3rd goes above your x's to the 3rd. All right, so that's the division step. Now we multiply it in. 2x to the 3rd times x is 2x to the 4th. They have to match. All right, 2x to the 3rd times negative 3 is negative 6x to the 3rd. So you see how it lines up? X is to the 4th, x is to the 3rd. All right, now we subtract. So 2x to the 4th, take away 2x to the 4th, they cancel. That's what we want. If they don't cancel, then you didn't pick the right piece up top. All right, then you have 0 x's to the 3rd, subtract negative 6. Subtracting a negative 6 turns to addition. That actually equals 6x to the 3rd. Do you need something?
I just need that.
Okay. You're okay, Rich?
I forgot it.
Okay. All right, and then we bring everything down, and we're going to do it again. All right, so now you should be asking yourself, how many times does x go into 6x to the 3rd? But I like to think of it as, what could I put up here so that when I multiply it with x, I get a 6x to the 3rd? And that would be a 6x squared. So give yourself a 6x squared up here. All right, 6x squared times x, there's my 6x to the 3rd. 6x squared times negative 3 is negative 18x squared. Now we subtract. Again, the front has to match, but this one doesn't. 6x to the 3rd, take away 6x to the 3rd, they cancel, that's what we want. Negative 15x squared, subtract negative 18 turns to plus, and you actually get 3x squared. All right, bring everything down, and let's do it again. Okay.
I'm sorry.
It's okay.
Here, I have a patent.
You got one?
Thank you so much.
You're fine. Okay, so now you should be asking yourself, how many times does x go into 3x squared? Or, like I like to think of it, what could I put up here so that when I multiply it with x, I get a 3x squared, a 3x. So now we need a 3x. So now 3x times x is 3x squared. That has to match. 3x times negative 3 is negative 9x. That doesn't have to match. All right, now we subtract. 3x squared, take away 3x squared cancels. That has to cancel. Negative 10x subtract negative 9 turns to plus. Negative 10 plus 9 is actually negative 1x. And then bring down the plus 5, and we should have to do this one more time. All right, how many times does x have to go into negative x? Or what could you put up here so that when you multiply it with x, you get a negative x? Negative 1. So now we need a negative 1. So negative 1 times x is negative x. That has to match. Negative 1 times negative 3 is positive 3. All right, and now we subtract. Negative x subtract negative x turns to plus. They cancel. 5 subtract 3 is 2. And since there's nothing left to bring down, that's your remainder. So remember, to write your remainder is weird. You have to write the remainder as part of this polynomial. So what you're going to do is you're going to say plus the remainder of 2, but you have to put it over who did you divide by? We divided by x minus 3. And this is what you would type in to Delta Math as your answer. So guys, again, I will never say that this is easy. This is definitely a process, but it's a very repetitive process. Divide, multiply, subtract, bring down, repeat, all right? And again, it's usually the subtraction step that makes people mess up the most because you have to pick up that subtraction. Okay, I wanted to show you that last problem. Now I want to show you the shortcut. So I did attach brand new notes for today. This was yesterday's notes. So guys, there were 2 more problems on yesterday's notes. So remember, they're going to write it like this. If 5x plus 3 is raised to the power of negative 1, then move it to the bottom. And now it's raised to the positive power of 1. So it's really just 25x squared minus 9 divided by 5x plus 3. And then you're trying to figure out how many times does 5x plus 3 go into 25x squared plus 0 x's and then minus 9. And then you could long divide that. I'm not going to do these ones out. I want to show you guys the shortcut today. All right? But I did fill them in on yesterday's notes if you want to take a peek at these ones. All right, let me bring up the new notes. Okay, so what I did is I took the 3 examples from yesterday. We actually just did this one. I put the 3 examples we did from yesterday with the answers that we got. I want to do all 3 of these problems over again using the shortcut. And you're going to see that the shortcut gets us the exact same answers. So I can prove to you, as short as the shortcut is, it is still working. It is still getting you the correct answer. All right, so let's read you each example using the shortcut, which is called synthetic division. Synthetic division is the shortcut to long division. But guys, it's only a shortcut to some of the problems. Some of the problems still have to be done by long division. Okay, so I call this part 4. This is the 4th type of polynomial division. When a polynomial of more than one term is divided by, and here's the key for the shortcut. Technically, synthetic division only works if you're dividing by a linear polynomial. Linear meaning degree 1, so no x squared, no x's to the third, just x. All right, a linear polynomial of the form x plus a or x minus a. So guys, technically synthetic division only works if you're dividing by something like x minus 4 or x plus 3 or x minus 1 or x plus 7. It only works if you're dividing by one of a polynomial that looks like this, a linear polynomial, okay? All right, so guys, here's example number 1. Let's redo it using the shortcut and watch that we get the same answer that we did yesterday. Okay, so to use synthetic division, first step, take who you're dividing by, x minus 5, and set it equal to 0. Guys, this is going to feel weird, but this is the process. We need to solve for what x would be as an answer if x minus 5 was one of his factors, if it did divide evenly in. So we get x equals 5. I call 5 our magic synthetic number. The book is going to call him A, because if this was x minus 5, A would have been 5. So I call him the magic number. So I want you to write him like this, and then draw a box like that. And again, once you get this process down, you're like, oh, wow, this is a lot easier than long division. But right now you don't know it, so all of this is going to feel really weird. Okay, so what synthetic division is going to do is it's going to do all of the long division for us by removing the variables. And all we have to do is work with the coefficients. We remove the variables from the situation, and we only work with the coefficients, the numbers in front. So guys, now go to the polynomial we're dividing into, which is x squared plus 3x minus 40. Look for missing terms. It goes from an x squared to an x to a just number, so we're not missing any. Now I want you to gather the coefficients. What's in front of x squared? 1. What's in front of x? 3. What's the number at the end by itself? Negative 40. So again, synthetic division takes the variables out of the process. We just work with the numbers in front. Okay, that's the setup. Now to get started, I want you to drop the first coefficient down underneath that line. Now, we're going to start a multiply, add process until we get to the end. We're going to multiply, add, all the way to the end. So take your first coefficient and multiply it with 5. What's 1 times 5? It's 5. Write that under the next coefficient. Now we add. What is 3 plus 5? 8. Okay, now we go back to multiplying. 8 times 5 is 40. Write it under the next coefficient. Now we add. What's negative 40 plus 40? 0. And then always circle the last number. The last number always represents the remainder. So this means the remainder is 0, which is what we love. It means that this divided into that evenly. So now what happens is, because synthetic division took the variables out, we need to put the variables back in. So these numbers down here, these are the coefficients to our answer polynomial. They're just missing the variables that go with them. So now we're going to put the variables back in with these new coefficients. So guys, if the original polynomial you were dividing into was degree 2, your answer polynomial always starts 1 degree less than the original. So if this was a degree 2, the answer is going to be a degree 1. So this is going to be a 1x. And then what comes after an x term? A just number. So the answer is x plus 8. And if you look up here, that's exactly the answer we got yesterday when we did this using long division. The first problem, the answer was x plus 8. And we just got the exact same answer using the shortcut, except we had to put those variables in. So guys, if this was a degree 3, then this would have started with an x squared. If this was an x to the 4th, then this would have started with an x to the 3rd. It always starts 1 degree less. Because guys, think about it. The first one into the first one, if an x goes into an x squared, it's always going to be 1 degree less than that as the answer, all right? And look how much little time that took to get to the answer. So again, it's weird. It's like, wow, I don't even know what just happened, but it gets you the right answer. And I would rather do that in the future than go through that long division process, all right? All right, let's try example 2. Let's try the shortcut again with example 2. So guys, if you remember from yesterday, example 2, the answer was 2x squared minus 5x plus 6. Let's see if we can get that using the shortcut. Are you guys okay? Everybody here okay? At home, can I get a thumbs up? Are we okay? All right, you're doing great, guys. Hang in. All right. All right, so notice how you're dividing by x minus 4. So that's like an x plus a, x minus a. So this qualifies as a problem that you could use the shortcut for. So guys, technically, pretend you were dividing by 3x minus 4. That technically doesn't qualify for synthetic division. That technically qualifies that it has to be done by long division. That doesn't technically qualify for synthetic. All right, here we go. So first things first, take who you're dividing by, x minus 4, and set it equal to 0. Now let's solve for x. What would we have gotten as an answer if this really was one of his factors? X equals 4. All right, so I like to call that's our magic multiplying number. So take them off to the side and then give yourself that open box again. Okay, now all we need are the coefficients to the polynomial that we're dividing into. But let's check for missing terms. X to the third, x squared, just x, just number. So it's not missing any, so we don't have to fill in any zeros. So I need a 2. I need that negative 13, don't lose their signs. I need that positive 26, and I need that negative 24. Okay, so we have our setup. Now to start, you always drop the first coefficient down underneath that line, and that's how we start this big multiply, add process all the way to the end. All right, ready? Here we go. 2 times 4 is 8, and now we add. What's negative 13 plus 8? Negative 5. All right, now we multiply. Negative 5 times positive 4 is negative 20. Now we add. 26 plus negative 20 is 6. All right, now we multiply. 6 times 4 is 24, and now we add. Negative 24 plus 24 is 0, and you always circle that last number because that last number always represents the remainder. So again, it means your remainder is 0, which is what we hope for when we divide. It means this divided evenly into that. Okay, so what's the answer? These are your new coefficients to your answer polynomial. You just got to put the variables back in. And the variables always start 1 degree less than the original. So since this is an x to the third, this one's going to start with an x squared. So that's going to be a 2x squared. That's going to be a minus 5. What should come after an x squared? A just x. And then what should come after a just x? A just number. And there is your answer polynomial. And it's the exact same answer that we got yesterday using long division. Again, you could be sitting here thinking like, oh man, this is so much easier. And I hope you are. But remember, it only works when you're dividing by a polynomial like that, like an x plus a or an x minus a. Everything else technically should be done using long division. All right, how do you guys feel? Everything's good? Nice and easy? Everybody at home, we're still good? Thumbs up? Okay, let's do the last one. Let's see if we can get the same answer from the one we just did. We just did this one at the beginning of class. All right, so notice I'm taking this polynomial and I'm dividing it by x minus 3. So that qualifies for synthetic division. Okay, so take what you're dividing by, x minus 3, set it equal to 0, and solve. X equals 3. Now, guys, obviously, if this was plus 3, then you would have gotten negative 3, and your number would have been negative. That's fine. You can have a negative magic number. All right, so take it, put it off to the side, and then give yourself that box. Okay, now I need my coefficients from the polynomial that I'm dividing into. But guys, notice, this goes from an x to the fourth to an x squared to a just x to a just number. It's missing those x's to the third. So we're still going to have to fill in the 0 to placehold. So when you bring your coefficients down, you're going to bring down a 0. All right, so I got a 2. Then I have a 0 as my next coefficient. Then I have a negative 15. Then I have a negative 10. And then I have a positive 5. All right, guys, let's all drop down our 2, and then I'll meet you at the end. Everybody do this multiply, add. Multiply, add. Let's see if we get the same thing at the end of the problem. I'll give you a little bit of a head start. You're always multiplying here and then adding down. Let me just double check the attendance real quick. No, Cam, I just saw your comment. It's not always a 0. You should see on this one. This one's going to have a remainder, just like we got in class at the very beginning. We want it to be a remainder of 0, obviously, when we're dividing, but unfortunately, then no, they're not all going to have a remainder of 0.
Okay, thank you.
Yep, and Dan, Justin, and Tomas, thank you for your messages. I appreciate that. All right, so guys, right now I'm just missing Jariza. Okay. Let's see if I can catch up. Okay, so if you remember at the very beginning of class, we had a remainder of 2. That last number is your remainder. And these are the coefficients of your answer polynomial. We got to put the variables back in. So guys, if this one was x to the 4th, this one starts with an x to the 3rd. So this is going to be a 2x to the 3rd. What comes after an x to the 3rd? An x squared, so that's a 6x squared. What comes after an x squared? A just x, that's a plus 3x. What comes after a just x? A just number. And then that's your remainder. So remember, we write the remainder as plus 2 over, who did we divide by? X minus 3. And that's your answer. And it's the exact same answer that we got at the very beginning of class. And we got it about 100 times faster. Okay. Guys here, how do you feel about synthetics? Everybody okay? Would you agree it's obviously a lot easier than long division, right? A lot quicker?
I'm just a little bit confused.
Okay.
The 0 and the x, like,
Yep.
where you're missing.
The problem is, if this polynomial doesn't have an x to the 3rd, that's fine, but maybe your answer needs one. And if you don't leave room for it, nothing lines up. So you have to leave room for the chance of there being an x to the 3rd in our answer. So the rule is, if it starts with an x to the 4th, then you have to be able to count your x's down. There should be room for an x to the 3rd, an x squared, a just x, and a just number. And anything that's missing, you got to put a 0 in for. Now, guys, with synthetic, sometimes, let's just pretend maybe you added and you got 0, right? Well, then what happens is, this one starts with an x to the 3rd. So it would be 2x to the 3rd, 0x squared, and then plus 3x minus 1. So sometimes you'll get a 0 here. It just means that whatever term that is, there isn't one in the answer, okay? And that's fine. All right. All right, perfect. All right, so guys, can I get a thumbs up at home that you are okay? All right, so what I'm going to do is, I didn't give you guys homework. I would like you guys to make sure that you finished yesterday's homework on the long division. And then tomorrow, I'll give you some problems to try in class with the synthetic. And then I'll probably give you a review on Thursday. And then we'll take a quiz on dividing on Friday. Okay? All right, so no new homework today. Just make sure you do the long division problems from yesterday, which obviously, if you haven't done them, some of them could be done this way, obviously now. All right. If you have any questions, please feel free to stay. Otherwise, let me just double check your attendance. And if I say your name, you will be good to go.